Hi, welcome to our 10:30 press conference, Climate Change and Winemaking in Quebec. Our participants are Philippe Roy, Climate Scenario Specialist at Uranos Consortium on Regional Climatology and Adaptation to Climate Change, Montreal, Quebec, Canada. Isabelle Charon, Climate Scenario Specialist at Uranos Consortium on Regional Climatology and Adaptation to Climate Change, Montreal, Quebec, Canada. And Evelyn Barriot, a wine grape specialist for the Quebec Ministry of Agriculture. Thank you.
So hello everyone, thanks for coming. So what we will show you today is an assessment of the winemaking potential in the coming decades over the agricultural region of Quebec. So we do this assessment through high resolution probabilistic scenarios. So the main question we want to answer is to quantify the probability to have an increased winemaking conditions over the province of Quebec in the next decades. Also, we want to know where and when. So before going into the main highlights of the research, maybe just a quick prior on the basics of winemaking suitability in terms of climatic conditions. So vine needs temperature for growth. So we developed a set of climate indices that will characterize the potential for vine. So we need a minimum number of consecutive days without ground frost. 150 days is the bare minimum. We need enough degree days. Degree days is the summation of degrees over a given threshold. In this case, it's over 10 degrees Celsius. And we also need gentle wintertime minimum temperatures. Though on this case, there are workarounds to reduce the vulnerabilities to brutal wintertime temperatures. So based on these indices, we estimate the probability to exceed some defined thresholds over the agricultural regions in Quebec. So for each of the three indices, we have thresholds like 900 degree days, 1,000 degree days, and so on. So each threshold will give an increase in the winemaking potential. So maybe the first highlight of the study is where are the new regions over Quebec. So as I said, we need a minimum of 900 degree days. So this figure shows the occurrence year where we have a probability higher than 80% to have 900 degree days. So we can see that the southern part of Abitibi around the decades 2020 and 2030, we have a probability higher than 80% to have this minimum threshold. So with this study, we can look at where the next region for winemaking could be located. So there are also other indices. In this case, what about the length of season without frost? For this case, 180 days is not the minimum threshold. This is actually the highest threshold. So in this case, the region that will emerge will be able to grow European types grape variety like Merlot, Pinot Noir, and etc. So as you can see, the spatial distribution is not necessarily the same. So we need to combine these two complementary information. So we will combine them and see where the region will be situated for the new grape variety. So in this case, we choose the Vinis vinifera grape variety, which is mostly European type grape variety, like Chardonnay, Pinot Noir, Cabernet Sauvignon, and so on. So instead of looking at the occurrence year where we will exceed a given threshold, we will set the time constant. So we will look at the 2050 time horizon, and we will estimate the probability to exceed these two thresholds. So what we can see here is that the southern part of Quebec and also along the St. Lawrence River, the probability to exceed these two thresholds, so 180 days and 1,250 degree days, will be around 90%, 80%. In this study, we actually focused on the Estrie region as an emerging region. So by the time horizon 2050, we can expect to have a probability about 70% to exceed these two important thresholds. So the main conclusion of this study is that by 2050, we can expect great winemaking potential in the southern part of the province of Quebec. And especially, we can expect to grow Vinis vinifera grape variety, though mainly the southern part of the province of Quebec. And a quick note that the winemaking in Quebec is still at an early stage, but things are looking good on the climate side of the next decade. So we might ask, how did we obtain these results? So we use CIMIP 5 simulation, which is a large ensemble of global models that simulate the climate over the next century. And we interpolate these coarse resolution onto a high resolution reference graded data sets, which is daily observation on at 10 kilometers grid. When we do the interpolation, there's no new information created, so we do a statistical adjustment of the simulations using the reference data set on a quantile mapping basis. So each daily value is corrected with respect to its own bias. So this, we smooth out the outliers, and we keep the climate change signal. Once we have these simulations, we have over 90 simulations. We simply do a calculation of the annual climate indices on an annual basis with different thresholds, and then the probability estimation is simply the summation of simulations that exceeds a given threshold. And since we have time series, we can estimate a new probability for each year. So as an example, what we have here is the accumulation of degree days over the Estrie region. And we have 4 different thresholds. And also we have more than 1 RCP, the dashed line being the RCP 8.8, and the solid line is the RCP 4.5. The RCP are simply different socioeconomic scenarios that will drive the climate in the next century. So with these time series of probability, we can estimate the year of occurrence. For example, when we will have more than 80% probability to have more than 1,100 degree days is around the year 2055 for this particular region. To combine these different indices, so we simply has the same mindset, is to, instead of asking the ensemble for a given threshold and a given indices, we ask every simulation what is the probability to exceed a set of simultaneous threshold. So this is the way that we use a combined composite probability. So the implication of these results is that the result shows that climate change is an opportunity for the wine growing sector, and that the probabilistic framework can provide rich information to decision making. And solely in terms of climatic conditions, we can expect increased winemaking potential in some regions like Estrie, Montérégie, along the St. Lawrence River, Outaouais River. And more generally speaking, the proposed probabilistic approach can be tailored to specific index thresholds or different studies. So, thank you. Isabelle will speak shortly for maybe 5 minutes.
So I'm going to spend a few minutes just explaining in a little bit more detail how we use climate information. So I first want to point out what our organization does very, very briefly. So Philippe and I work at URANAS, which is a climate change consortium on regional climatology and adaptation to climate change. So our goal is to provide usable information that is applied, so applied science, applied climate information, so that users can base decisions on that information. There are a number of different programs in our organization, a climate simulation group, which works really on climate models, at climate scenarios. Philippe and I are both part of that group, where we tailor the climate outputs into something that the vulnerability impacts and adaptation community can use. So as you can see, we have 10 different programs. So we work on agriculture, energy, built environment, tourism, etc. So our goal really is to provide information that different users can understand and can use. So in this specific example, we have to understand that we're providing information that will be tailored to different stakeholders based on their expertise, based on their experience, based on their preferences. But for that any given issue, you are likely to have more than one stakeholder or decision maker. You have, for example, people in the government, or in this case, people from the industry that are trying to regulate the wine industry, and you have the actual producer on the ground that's also having to make decisions. So the information that you produce has to be able to fit the needs of all of these different people. So I'll just show you how we can tailor that information for them. We also have to keep in mind that we provide climate information, but while we talk to users, while we help users, we also have to keep in mind that other factors outside of climate change will also be important, and I'll come back to that a little bit in a minute. So I'm going to show you two ways to view climate information. One, looking at climate information in time. So looking at information, for example, on the recent past or current climate information and comparing that to what's happening in the future. So if you're looking at the past, so if you look at the figure on the bottom left-hand side is showing you a black line, which is the actual observed number of growing degree days over the recent past, 1960 up until now. So that information in and of itself can help people decide, can wine actually be produced in this region right now? So I'm only showing you growing degree days. Philippe just showed us that there are other variables that need to be considered, but just giving you an example here. So looking at the past can tell us, well, can we actually produce wine? Is the climate already having an impact on the production right now, on the quantity, on the quality of the wine? And it helps us establish relationships between the climate and our wine species. So that relationship is needed in order to decide whether the climate is going to have an influence on winemaking. You can also see, looking at the observed here, that not one year is exactly the same as the one previous or the next. So there's already a natural variability that the producers are used to, that they have to be able to handle in their current production. When we look at future model simulations, so now you're looking at the far end of the figure, what the models are telling us. Here you have the ensemble, CMIP 5 ensemble that Philippe showed you before, using two different emission scenarios. So RCP 4.5 in blue and RCP 8.5 in green. So the more emission scenarios you have, the larger the change is going to be. But this is helping us decide whether climate is going to have an impact on your production. Is winemaking going to become possible in the future based on this information? But you can also look at the information in space. So looking at gridded data, so putting that information on the grid where you spatially look at where you can grow wine. And actually, this is not the figure I wanted, but that's okay. So what you're looking at is, on a larger scale, here we're looking at number of days without frost, so a different index. If you're thinking of it as an industry question, they can start asking, well, are some areas more likely to become suitable or less suitable for winemaking in the future? Is there potential for new wines, new variety of grapes to be grown in different regions? Can we start using this information to zone regions for different appellations in winemaking, for example? If we look at a very, very small spatial scale, so I've zoomed in on the Estrie region, which Philippe showed before as well, so the producer can start asking, well, can I start optimizing my production? Are there going to be more frost days that I need to start protecting my vine species in the winter, for example? What can I do on the ground right now? or in the future to protect my, my industry, my production? Will I be able to grow new varieties in my field as well? So these are the kinds of questions that we can start asking using the climate information that we produce. But you have to keep in mind that this is one piece of the puzzle, so it's just the climate, a few climate indices. When you start talking about wine, there are other factors that will also come into play. So the climate perhaps is looking good in the future, but once you have that information, you also have to start asking, well, is the soil the right type of soil? Do we have the right topography? Do we have the right terrain orientation? So there are other factors that also have to be considered when you're going to decide whether winemaking is going to be possible. There are other factors that are also influenced by the climate. Pathogens, invasive species. So those as well will be influenced and have to also come into play when you're using, when you're trying to make decisions based on climate change. Thank you. That's it. So I think Evelyn is our expert on wine, grape species, and so she's not talking right now. She doesn't have a formal presentation, but she'll help us answer your questions if you have any.
So we'll now open the floor to questions. Does anyone in the room have any questions? Are there any questions on the chat? Not yet. We'll take a little pause, perhaps. Someone is typing. Questions are pending.
Yeah.
Okay, so this question is from Joanna Wendell at EOS. Why did you choose the two thresholds, growing degree days and days of frost? And what is important about those two thresholds?
Well, there are 4 thresholds for each of these 2 indices. So just give me one moment. Like for the degree days in base 10, the 900 degree days is the bare minimum for vine growing. So this one is clearly evident. In this study, we actually used the 4 thresholds, and we look at the whole maps. So for this presentation, I just chose 900 because, well, I think it's the one of the interesting questions is to see whether or not a given region will be able to grow vine in the coming decades. And for the number of consecutive days, the bare minimum is 150. But I think most of the people, when I talk about that, is that they want to know when can we grow Pinot Noir. So we need more than 150 days. So that's why I choose maybe the highest threshold to see whether or not we will be able to grow some more diversified grape variety. So about that, I don't know if you, Evelyn, have something more to say, or?
Yeah, growing degree days and frost-free days are very important in order to get ripened fruit, to get good maturity and good wine, make good wine. So it's really important. And right now we have cool climate variety that ripen early, and in a future climate with more heat unit, we will be able to grow other variety, as Philippe mentioned.
Any additional questions? No, I think that's it. That concludes our press conference. Thank you.
Thank you.
Our next this is our last press conference for today. Our next press conference will be tomorrow, Tuesday at 10:30 a.m. on the latest scientific results from the Mount Poly mine failure. Thank you.
Ouais, bon.